So let's talk about thermodynamics today because I know these types of questions can be a little bit specific, a little bit confusing, not because of the amount of formulas or complicated or misunderstanding. I think it's more about correct signs of the enthalpy, of the heat capacity, and so on. So let's see what's going to be given to us in this question and let's solve it together. First, I always recommend to write out what's given to us. Here it is. We have mass of copper, 52.3, right? Copper weight, 52.3 grams, is heated by a flame from room temperature 25 Celsius to a temperature 189 Celsius. Well, right away we can find delta T, which is difference in temperature, which is 189 minus 25, will give you 164 Celsius. Specific heat capacity, which is C of copper, is 0.385 joules gram times Celsius. So what we do here is, and we need to find the enthalpy change, of course. By the way, heat capacity is always going to be given to you, or you will be able to find it from the table. They don't ask you to find it unless every single letter from the formula is provided. But usually that's not the case. They usually want you to find enthalpy change. This would have temperature changing from 25 to 189. That means we increase the temperature. Therefore, delta H will be negative. Negative sign. Why is it going to be negative? Because it's exothermic reaction. Because we are giving away the energy. The system does not require the energy, the temperature, right? In this case, it produces the energy. That's why it's exothermic reaction. Now, the main formula we're going to use is QmC delta T. Why? There is no mention that we have bomb calorimeter. Therefore, it's coffee cup calorimeter. And therefore, P is equal to constant. And we should know that if P is equal to constant, delta H will also be equal to that formula. That's it. So let me repeat it once again. Since in the whole question over here, we don't have mentioning of the bomb calorimeter, therefore it's coffee cup calorimeter. We have only two types of calorimeter. If it's coffee cup calorimeter, pressure is constant, so does not change. Since it doesn't change, we use that formula for delta H. Do we have all of that? Yes, we do. So delta H, let's just plug in all the numbers. Delta H will be 164 times 52.3 times 0.385. Of course, everywhere we should put units. So actually, let's fix that problem. Joules, grams, Celsius. And you can see that Celsius will be canceled over here. Grams will be canceled over here. What are we left with? With joules. So the answer here is 3,302.2. But remember what we said, delta H will be negative. So I'm putting a negative sign. Even though according to the math, I didn't get a negative, I still am getting negative because it's exothermic reaction. Now imagine if we have a question, what is delta H for water? For coffee cup calorimeter, we know that it's basically reactions happening here and the water is outside, like surroundings. Reef reaction is giving away the energy, right? Does the temperature increase of the water? Yes, it does. But basically, that's what's happening. And there is a rule. If delta H of the reaction is negative, so delta H of the water will be positive. Therefore, it's going to be 3,302.2. That's all. And of course, don't forget the units. Joule, joule, joule.